In this lesson, we're going to be looking at the midpoint of a line, and in order to talk about the midpoint of a line, typically we've constructed lines by drawing between 2 points. So I'm going to backtrack all the way to the 2 points themselves, and let's start our discussion with that. If I take a look at these 2 points, you can see that both of them have the same y coordinate. So essentially the line, if we drew one here, would be a horizontal line. So I'm just going to put a line in between them, and that line could extend in both directions obviously and carry on, and just to move this a little bit so that's still visible. Okay, so that being the case, if I approach this more like an even simpler problem, imagine this was the number line. So we're only going to be looking at x coordinates for this first one, this horizontal line. So if this is 1, then we have 2, 3, 4, 5, 6, 7, 8, and of course 9 at the end. Now visually, you can probably see where the midpoint is for this already, and it's right there. So the midpoint of this line is at, if this is 1, this is the point 1, 2, so this is 2, 3, 4, 5. Okay, so the midpoint is at 5, 2. Now, is there a way that we could have come up with, and this is what we're working towards, can we come up with these values based on the values of the points, the x and y coordinates of the points? In this case, fairly simple. The y coordinate just didn't change because it's a horizontal line. Now, what about the x coordinate? Is there something I can do with the numbers 1 and 9 that result in me getting a 5? So think about that. What could I do with a 1 and a 9 to get a 5? And the answer to that, or at least one way you could think about that, is, well, if I added 1 and 9 together, that would give me 10. And if I divided by 2, 10 divided by 2 is equal to 5. So this idea of addition and then division by 2, let's see if that continues to work going forward. Now we've got a vertical line, and we're being asked to find the midpoint of this line. So draw in my vertical line. And let's find the midpoint of that one. Okay, well in this case here is the y values are the things that are changing this time. So this is y equals, there's 2, and then we've got 3, 4, 5, 6, 7, and 8. And if we take a look here again, just looking visually, you can see that the midpoint is here. But if you can't see that, 1, 2, 3, so the distance from here to here is 3, and 1, 2, 3, the distance from here to here is 3. Obviously, that's the midpoint in between, and this is the point. The x coordinate hasn't changed. It's still an x coordinate of 1, and the y coordinate is 5. When we looked at the x's, we had this idea of adding and dividing by 2. So rather than speculating this time, let's see whether or not that holds up. So now let's look at these y values. The x values haven't changed, so we can just focus on the y values. So we want to take the numbers 2 and 8, and we want to end up with a 5. And you can probably see that, yeah, that's going to work. 2 plus 8 divided by 2 is going to give me a 5. 2 plus 8 is 10, divided by 2 gives me 5. Now with these, it's so easy, and as this is often the case when we're teaching a new concept in mathematics, why would I bother doing this when I can see that so easily from my diagram? Two good reasons for that. One, your diagram isn't always going to be dealing with nice points. It's not always going to be something you can come up with visually. And two, you might not always have a diagram. We quite often work towards coming up with things algebraically. This is the first example. Here I have something that's not very nice. Let's go back. Sorry. This one is still very nice. It's actually using both of the concepts from before, except for now my line is no longer horizontal or vertical. My line actually goes through these 2 points in a more typical arrangement, in the sense that It's not designed to be dead easy with just a horizontal and vertical line. But there are some things that we can make use of here, which is, for example, if I were to put in, let's do a dashed line. Horizontally, this line goes from here to here, and vertically, we're going up like that. And you can see I've constructed something like I've got a right angle triangle here. We've seen this kind of shape before when we're looking at slopes. And now, if we look at it this way, well, let's imagine the horizontal. So the coordinates of this point would be the point, the x coordinate is going to be 9, that comes from here, but the y coordinate is equal to 2, which comes from here. But we looked at 1, 2, and 9, 2 before, and we found that the midpoint between 1, 2, and 9, 2 was equal to 1 plus 9 is 10, divided by 2 is 5, 2. Now let's take a look vertically here. We've got 9, 2, and 9, 8. So you can see the 9 isn't changing. What's changing is the y coordinate between 2 and 8. And we did that in our previous example. Between 2 and 8, we ended up with 8 plus 2 is 10, divided by 2 is 5. And so this is going to have a y coordinate of 5. And the x coordinate stays the same. It stays 9. Well, how has that helped me? I found the horizontal mid and I found the vertical mid, but the last step we're going to take from here is say, okay, well, where does this midpoint and this one, what does that mean? I found, let me say this another way, here I found the midpoint of the x's. Here I found the midpoint of the y's. And so it stands to reason that the midpoint along this solid line is actually the combination of the midpoint of the x's, which is 1 plus 9 divided by 2. So 1 plus 9 divided by 2. And the y coordinate is going to be the midpoint of the y's, which is 8 plus 2 divided by 2. And what is that equal to? 1 plus 9 divided by 2 is 5. 8 plus 2 divided by 2, 10 divided by 2 is also 5. And it turns out that this is the point, just visually, we can read across here the x coordinate 1, 2, 3, 4, 5, the y coordinate 1, 2, 3, 4, 5. So it looks like what we've come up with, the idea of adding and dividing by 2, is going to apply regardless of where these points are. And let's take a look now at one where the points are not so nice. I've introduced some decimals here. Just a reminder, if you're given your question in decimals, it's a pretty good chance that you're going to be able to continue to work in decimals. I'm giving you kind of that permission to do so. So let's put in our line. And now let's find where the midpoint is. Now, I can kind of eyeball my midpoint here, but not really well. I'm not really positive where it is. So this is where the idea of the diagram starts to break down on us. So instead, what we start to do is make use of the algebraic idea, which is we take the x coordinates. I'm going to take my x coordinates of the first point, so let's call this x1 and let's call this y1. Let's call this x2 and let's call this y2. So I'm going to take the x coordinate of the first point, which is 1.5. I'm going to add to that the x coordinate of the second point, and that's 9. And I'm going to divide that by 2. Then I'm going to take the y coordinates. So the y coordinate of the first point, which is 2, plus the x coordinate of the first point, which is 6.5, divide by 2. And that is equal to 1.5 plus 9 is 10.5 divided by 2. 2 plus 6.5 is 8.5 divided by 2. And that ends up giving me 5.25 and 4.25. Now it's unlikely I would have been able to pick out this point, 5.25 and 4.25, just from the graph. Let's find those. 1, 2, 3, 4, 5.25, which would be around here. And let's double check that. 1, 2, 3, 4.25. And you can see that lines up just about right. So 5.25 is around there. 4.25 is around there. And you can see that that does actually look like the midpoint between these 2 points. Okay, so it seems like this has some validity to it. Okay, so we've already talked about this. I went through those examples. So it starts with the idea of a line segment. It starts with the idea that the midpoint of a line segment is the point halfway between the two endpoints. So again, once again, you can see here, it's very obvious between 1 and 5. The midpoint is here at 3, but is there a better way, a more algebraic way to find that? We add the two values, 1 plus 5, and divide by 2, and that gives me 6 divided by 2, which gives me 3. And that is that value right there. If I move down, in this case I've got -4 and +2. I do it the same way. Visually we can see it looks like my answer is going to be here at -1. So I put in my -4 and I add to that. And if you want to use brackets, especially if you're dealing with negative values, you might want to use brackets just to be on the safe side. And that is equal to -4 plus 2 is -2 divided by 2, and -2 divided by 2 is equal to -1, which is our midpoint right there. So that also works out, finding the halfway between. So this is really what we've come up with. We've got these two separate expressions. The midpoint of the x values, we take the x coordinates, add them together, divide by 2. The midpoint of the y values, we take the y values together, divide by 2. And we end up with the midpoint formula, which is this is the formula for an entire point. You can see the x coordinate is built in, the y coordinate is built in. I stress that down here. One place where students can start to encounter difficulties here is between this definition and the definition for slope, because the definition for slope, which is delta y over delta x, is equal to y2 minus y1 over x2 minus x1. You can see they're not really similar, but there's enough similar components to it that could cause confusion. This is lowercase m, this is capital M. The x1, x2, y1, y2 are all present. There's division by 2, no division by 2, addition versus subtraction. So that's why it's very important to understand these different things. You can't just memorize your way through these, because as soon as you slip up, you're going to end up writing something that just makes no sense at all. You need to understand where these things are coming from so that when you are doing the work, not only can you remember a formula or a concept, but you know which formula, which concept to apply at the right time. Okay, so an example here, we're not going to graph. We're not even going to look at a graph. We just have our 2 points. So I'm going to label these x1, y1, x2, y2. Things can get really quite tricky if you're asked to find midpoints and slopes at the same time. Now you're making use of all these numbers, but you're not always sure. Unless you're sure, you could easily make a mistake between them. So we are trying to find the midpoint, which is equal to x1 plus x2 over 2, y1 plus y2 over 2, and that is equal to x1 plus x2, that's -2 plus 4. Generally, if it's not a negative, you don't have to put it in brackets, divided by 2, and y1, which is -3, plus y2, which is 7, divided by 2, and don't forget this is a point, so we have to put brackets around the whole thing. -2 plus 4 is 2, divided by 2. -3 plus 7 is 4, divided by 2. and that is equal to the point 1 comma 2. And that's it. You're done now. That's as far as you need to go. You don't need a therefore statement here because there's nothing else you've answered. This is your answer. This is the point. One endpoint of a line segment is at 1, 2, and it has a midpoint of 5, 5. What is the other endpoint? Now this is interesting because we actually are not being told the two endpoints. We're being told one endpoint and one midpoint. So we actually know, let me write this out for you. The midpoint is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2, and that's a point. Well, this is one of my points, so I'm going to call that x1 and y1. This is my midpoint. So this is interesting because now, what do I do with this information? It doesn't go in the right side of this formula. It goes in the left side. The midpoint is actually 5, 5. Is equal to, now what was x1? That was the number 1 plus x2 over 2. And what was y1? y1 was 2 plus y2 over 2. And as you can see, here's our midpoint. Here is the x coordinate of our midpoint. Here's the y coordinate of the midpoint. So the things we don't know are the x coordinate of the second point and the y coordinate of the second point. So we are actually going to use this formula to solve for each of these, but we're going to do it separately. If this is the x coordinate of the midpoint, but the formula says that this is also the x coordinate of the midpoint, these two things are the same. And if that's the case, then I can actually write, now how you write this, you could write this one first and this one second. The way they're written here, I'll just go ahead and write it like this. 5 equals 1 plus x2 over 2. Or you could have written this as 1 plus x2 over 2 equals 5. Entirely up to you. These are identical. There's no difference between them. And I'll switch to another color. If this is the y coordinate of the midpoint and this is the y coordinate of the midpoint, then these two things must be equal to each other. And that means that 5 is equal to 2 plus y2 over 2. Or we could write that as 2 plus y2 over 2 equals 5. Either of those is perfectly good. You could even go so far as you could have written this as y2 plus 2, x2 plus 1, just swapping. Addition can be swapped back and forth at your discretion. So if you can accept what we've got written here so far, we can proceed to find x2 and y2. Now the way I deal with this, first thing you need to remember is whenever something's written in a fraction like this, that means there's brackets. We don't write the brackets, but that's what it means. So it's this whole thing divided by this whole thing. So the way we get rid of this on both sides is to multiply through by 2. Some people remember that also as cross multiplying. So what I'm going to do here is I'm going to multiply everything by 2. I use square brackets here to say I'm doing this to both sides. That's what that little notation means. I'm going to multiply both sides by 2. And so what do I get? Well, the reason I multiplied, I had division by 2. If I multiply by 2, that just turns into 2 over 2, which is 1. So this becomes 1 plus x2. And the right side multiplied by 2 becomes 10. To get x2 by itself, I have to subtract 1 from both sides. And I end up with x2 is equal to 9. For this other one, I actually have to do the same thing. I'm multiplying both sides by 2. You know what? Let me show you the other way that you could denote this. Is you could also just go ahead, if you wanted to, and put in a multiplied by 2. So you might do something I don't like to use x's. I don't like to write this when we have x as a variable. So what I'm going to recommend instead is we write 2 bracket. So that's what I'm adding. And then this one's going to be times 2. So what I've put in black there is what I've added. We've got 2 in the numerator, 2 in the denominator. That divides out, giving me a 1 and a 1. And of course, 1 over 1 is just 1. So this becomes 2 plus y2 equals, I think I need to write a separation line here. 2 plus y2 equals 10. I'm going to subtract 2 from both sides. And I end up with y2 is equal to 8. And so my solution, or it's not a solution in this case, we're not solving, we're finding the midpoint. Therefore, the midpoint is, the x-coordinate is 9 and the y-coordinate is 8. And this is actually, these are the points from one of our graphical examples before. The midpoint was 5, 5. One of the points was 1, 2. And you know what? I have messed up this. This is not the midpoint. Why didn't you correct me? You guys are supposed to be shouting at the screen right now. It's not the midpoint. It is the endpoint, or the other endpoint. The other endpoint is 9, 8. That's what we were asked to find. So you can see it's important to go back and reread the question, because even there I slipped up and I left that in the video. You can see that I'm also prone to making mistakes. Okay, moving on. We have, oh, that's it. That was our last example. Okay, so one thing, I just really want to bring it back to this last one we did. You're not always going to be finding the midpoint. Sometimes you're going to be using the idea of a midpoint to find something else. And that's it for our discussion on midpoints.